Okay, so what we're going to do now is we're going to use our trigonometric identities and the Pythagoras theorem to solve for all the missing information on the triangle that's up here. So we are going to solve for this side. We are also going to solve for the measurements of both angle A and angle B. And we're going to solve, so we're going to, may as well just label these A, B, C, C, A, B. So we're going to solve for side B, and we're going to solve for angles alpha and theta. So the first step here is we're going to use the Pythagoras theorem to solve for our missing side. So Pythagoras is a squared plus b squared equals c squared. We know a and c. So 4.3 squared plus b squared equals 9.3 squared. So that would mean b squared plus a squared, which would be 18.49, equals 9.3 squared, which would be 86.49. Subtract those. B squared is equal to, I'm going to use my calculator, 86.49 minus 18.49 equals 68. And square root of 68 would be square root of 68 would be 8.2. centimeters. So that solves for our B. Why did I round it to 8.2? Well, that's the significant digits. All the other values given in the equation or in the problem are to 1 decimal place. So in my solution, I'm also going to round to 1 decimal place. Now, for the sake of simplicity and space, I'm going to erase this. If you want to jot it down, now would be a time to pause the video, and you can review this. Next thing I'm going to do is I'm going to use my trigonometric ratios to solve for the missing angles. Now, in this case, let's solve for angle B. So this is our hypotenuse. This is our adjacent. This is our opposite. So here we're going to use cosine, which is equal to adjacent over hypotenuse. So more specifically, cosine of angle B, or depending on how I want to write this, cosine of theta. I'm going to go with cosine of angle B today. Cosine of angle B is equal to adjacent over hypotenuse. Adjacent over hypotenuse is 4.3 over 9.3. This will be cosine of angle B. Now, from last year, hopefully you remember, the opposite of the cosine, move this around, is the inverse cosine, or cosine -1. So angle B is equal to the inverse cosine of 4.3 divided by 9.3. And you can plug those values into your calculator and you will get angle B is equal to 62.5 degrees. That's fairly straightforward. Now, again, you guys are probably a little bit out of practice doing this on your calculator. Remember the inverse cosine, you're using second function button on your calculator to get the inverse cosine. Now, so that gives us one angle. We got 62.5 degrees over here. Well, this is a right angle, so that's 90 degrees over here. The sum of all the angles of a triangle is 180 degrees. So we already have 90 and 62.5. So to find the missing angle, 90 degrees minus 62.5 degrees gives us 27.5 degrees over here. Now, quite often in a question, you're only going to be asked to find one side or only going to be asked to find one additional angle. But the simple fact is, given any two pieces of information, using trigonometry, you can solve for all the parts of the triangle. As long as you know two sides of the triangle or one side and an angle, you can solve for everything else. You only need those two bits of information, Pythagorean theorem, and your trigonometric identities to solve the entire triangle. Too long.